much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Manulenyo.
Manood na sa teleradyo, makinig, manood na sa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Grade 8 students, hindi nyo ba maintindihan ang math lessons sa linggong ito? Hirap intindihin ang basic postulates or theorems sa geometry. Sagot ko, ang problema nyo. Kaya ano pang hinihintay nyo, mga batang malulenyo? Tara, mag-aral tayo dito sa Teleradyo Marcelo.
Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Hello and good morning, Del Pilarians. Welcome to the Q3 Week 5 Teleradyo Marcelo episode of Mathematics 8, ang telearalan ng bawat malulenyo. Bago ang lahat, kumusta kayo? Sana nasa mabuti kayong kalagayan. Pasasalamat sa mga teachers na nagsishare nitong ating Facebook Live. Maraming salamat po. Sa ating mga magulang na sumusuporta sa kanilang mga anak sa pag-aaral, saludo po kami sa inyo. Lalo na sa lahat sa mga teachers ko sa Mathematics Department at sa Junior High School Department, pati na rin ang ating administrasyon sa Marcelo H. Del Pilar National High School. Maraming salamat po. At sana nasa mabuti po kayong kalagayan. This episode is, of course, made possible by the Teleradyo Marcelo team and Junior High School Mathematics Department. I am Mr. Richard Cruz, your Mathematics 8 teacher broadcaster. For today's episode, we will discuss Q3 Week 5 lesson entitled Solving Corresponding Parts of Congruent Triangles. So, we would like to get the attention of the grade 8 students, especially those who experience difficulties during the lesson. Throughout the episode, we will learn how to prove and solve corresponding parts of congruent triangles. With that, we will use the different triangle congruence postulates and theorems that were discussed by Ma'am Charito Ferrer from the previous Teleradyo episode. You will also be able to illustrate properties of isosceles triangles. So, bring out your paper, pencil, and snacks, take your most comfortable seat, and let's get started. Let's take a quick review by identifying the triangle congruence postulate shown. You may post your answers on the comment box with your full name and section. First one, we have triangle MPN and triangle RSQ. What do you think is the triangle congruence postulate shown? Having corresponding parts like side QS corresponds side NP, angle S corresponds angle P, and side MP corresponds side RS. What do you think is the triangle congruence postulate shown? Correct. Triangle MPN is congruent to triangle RSQ by the SAS postulate. S represents the side, A represents the angle, which is to be specific, we call it the included angle, and another side of those triangles. Great job. Next, let's have triangle ABC congruent to triangle DEF. What is, again, the triangle congruence postulate shown? Having all three sides are congruent. Have you noticed their markings? Yes, that's your clue. Correct. Triangle ABC is congruent to triangle DEF by SSS postulate. No other than side, 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 because triangles only have three sides, not inside and outside. Last, how about triangle ACB and triangle DFE? Have you noticed the markings on the angles and one side? Again, do you remember that side in between those angles? Correct. That's the included side. Therefore, triangle ABC is congruent to triangle DEF by ASA postulate. The same thing with the SAS postulate, we have here an included part. Since we have two angles that are congruent, we have one included side in between those angles. Do you remember the properties and techniques in solving for an unknown value? Let's say, for example, x. Let's recall those steps in solving for the value of x as shown in this example equation. You may post your answers on the comment box again with your full name and section. Let's see. We have here the equation 7x minus 2 is equal to 4x plus 16. Again, that's 7x minus 2 is equal to 4x plus 16. Can you recall those steps or solutions? Supported by properties of equalities. Let's see the next step. By subtraction property of equality, we inserted negative 4x on both sides of the equation, simplifying 7x minus 4x minus 2 is equal to 4x minus 4x plus 16. What do you think is the next step? Correct. By simplifying 7x minus 4x, we will have 3x minus 2. Where's the 4x minus 4x? Correct. That's 0. Therefore, 16 will be left alone. But not anymore. With the addition property of equality, on the other side, on both sides of the equation, we will add 2 or insert positive 2. Therefore, we will have 3x minus 2 plus 2 is equal to 16 plus 2. Therefore, by simplification again, 3x is equal to 18. After that, let's ask, what is the number multiplied to 3 that will give you 18? Or 3x divided by 3 is equal to 18 divided by 3. Yes, that's x is equal to 6 by division property of equality. Great job! Those postulates and properties, as well as the technique, are essential in understanding our topic later. As you have noticed, our lessons for the third quarter are more on investigating properties of triangles, with clues and properties supported by definitions, postulates, and theorems. However, we are challenged to think deeper and imagine things that can only be represented by simple objects around us. Triangles are not used for aesthetic design. Triangles are known to be the sturdiest figure in the architecture world. If the design of a building is triangular, the design has a heavy base, just like the pyramids. Architects commonly use this shape to construct their buildings, and architects and engineers use triangle congruence to help measure the forces applied on the building to make sure that the forces are balanced and that the building will not collapse. Triangle congruency is required in marvelous architectural structures, such as the beautiful Louvre Museum in Paris. That's in France, home of the magnificent artworks. The Louvre Museum takes good care of Leonardo da Vinci's masterpieces. Yes, the Mona Lisa. That's one of those. To add elegance, the museum has the famous pyramid roof made up of glass. Don't worry, I will not ask you to count the number of triangular pieces used for the structure. With that, warm up your brain and test your eyesight with this challenge. So, here's the puzzle for you to identify the missing piece. That's for our warm up. Solve the puzzle. Post your answers on the comment box with your full name and section. Afterwards, your mathematics teachers will check your answers. Have you seen them? Which is the missing piece? Is it letter A, B, or C? 60 seconds. There you go. Very good, class. All of your answers on comment box is letter B, and that is correct. Letter B. Let's see. There you go. Yes, that's letter B. I think that's a great warm up, and it's a sign that we are now prepared for the next challenges. During the discussion, your active participation is highly encouraged by writing your answers on the comment box. We discourage commenting unnecessary words or phrases that are not related to the subject. So, let's proceed and make this learning fun and easy. To give you a glimpse of our learning journey, here are the questions for your guide. The first one is, what do you mean by CPCTC? Sounds familiar, right? And how do you prove triangle congruence using CPCTC? Third one, how are we going to solve corresponding parts of congruent triangles? When we say parts, those are sides and angles. Fourth one, and the last one, What are the properties of an isosceles triangle? What do you mean by an isosceles triangle? We will also discuss the theorem, corollaries, and some converse of this isosceles triangle. What is CPCTC? CPCTC stands for corresponding parts of congruent triangles are congruent. That's it. As easy as that. Now, let's make it easier by maybe cooking some sinigang from the market, ingredients from the market. Let's relate the CPCTC on our daily lives. Given that Aling Karen's basket is congruent to the basket of Aling Marites, we have Aling Karen and Aling Marites. Find the missing item. Is it A, B, or C? We have kangkong, labanos, sibuyas na pula, and kamatis. Perfect for sinigang, right? Why not letter A? Yes, because referring to Karen's basket, there are only 3 tomatoes. Why not letter B? Maybe those are large enough to fit to Marites' basket, which is not congruent to the corresponding tomato of Karen. Maybe if she used that tomato on letter B, that will be a bit sour with tomatoes, right? So the correct answer is letter C. Very good. That's just the right tangy taste of that tomato for that perfect sinigang. Whether it be fish, pork, maybe beef for your sinigang. So that Aling Karen's basket is now congruent to Aling Marites. That's it. That's the CPCTC. Now, let's use that for our triangles. Given triangle ABC is congruent to triangle XYZ, we already proved, let's say for example, and we assumed the triangle ABC is congruent to triangle XYZ. What are the corresponding parts? Triangle ABC is in blue and triangle XYZ is in green. When we say about parts, when we talk about parts, we are talking about the angles. How many angles are there for a triangle? Yes, we have 3. First one, angle A corresponds angle X, or angle A is congruent to angle X. That is our top vertex or top angle of from each triangle. Therefore, the measure of angle A is equal to the measure of angle X. If angle A measures 50 degrees, therefore angle X is no less than, is of course equal to 50 degrees. How about the second angle? Angle B corresponds angle Y, therefore angle B is congruent to angle Y. Or the measure of angle B is congruent to the measure of angle Y. Have you seen those 2 markings, 2 red markings on each triangle? Yes, that represents the angle measure. Having 3 markings on each triangle, we notice that angle C is congruent to angle Z. Therefore, angle C is congruent to angle Z, or angle C corresponds angle Z. And the measure of angle C is equal to the measure of angle Z. We're done with the 3 angles. How about the 3 sides? Yes. Side AB corresponds side XY. Have you seen those markings on each side? 1 marking on each side. Therefore, side AB is congruent to side XY, or AB is equal to XY. 2 markings on each side Yes, that's side BC corresponds side YZ. Or side BC is congruent to side YZ and BC is equal to YZ. Last one, the third one, side AC corresponds side XZ. Therefore, we may say that side AC is congruent to side XZ, or the measure of AC is equal to the measure of XZ. Yes, do you recall the corresponding angles and corresponding sides from the congruent sides and congruent angle definition? Let's proceed. How to prove triangle congruence by CPCTC, or corresponding parts of congruent triangles are congruent. The technique for this one is first prove that two or those triangles are congruent. And then afterwards, we may now prove that all of those corresponding parts are also congruent. We were given N is the midpoint of side AB. Therefore, N is in the middle of AB. Side AX is congruent to side NY. That's given. As well as side NX is congruent to side BY. Let us prove that the angles X and Y are congruent. Here are the steps. The first statement should be N the midpoint of side AB. What's the reason? Yes, that is given. And it follows that side AN is congruent to side NB. Since point N is in the middle of side AB, it divides that segment into two equal parts. Yes, that's the definition of midpoint. As you can see, we have a marking on each side. Segment AN and segment NB, or side AN and side NB. If they have those markings, yes, they are congruent or equal side. And after that, we have side AX is congruent to side NY. Yes, that is also given. As well as side NX is congruent to side BY, which is also given. Have you noticed the markings on each side of the triangles following the corresponding sides? Now, you had a clue which triangle congruence postulate is used. Therefore, triangle AXN is congruent to triangle NYB by side-side-side or SSS triangle congruence postulate. As easy as that. But we're not yet done. We have to prove that angle X is congruent to angle Y. Yes, that's corresponding parts of congruent triangles are congruent. Again, when we say corresponding parts of congruent triangles are congruent, that is the reason that we may use proven that that is the part of two proven congruent triangles. Now, how are we going to solve corresponding parts of congruent triangles? We were given that triangle ABC is congruent to triangle PQR. Let's solve for the value of X. We may have the solution side AB is congruent to side PQ. Why? Why did we come up with that solution? It's as easy as CPCTC. Since they are the corresponding sides of each congruent triangles, we may now use the congruency. And side AB is equal to 3x plus 4, and side PQ is equal to negative 3x plus 10. Yes, that's by definition of congruent segments or sides. We may now use their measures, but by this time, the measures are in algebraic expression. We may now use the equation followed by CPCTC from side AB is congruent to side PQ as the definition of congruent segments or sides. What's next? What is the second step? Correct. By addition property of equality, we may insert positive 3x on each side of the equation, one on the left and one on the right. 3x plus 3x plus 4 is equal to negative 3x plus 3x plus 10. Remember, our goal here is to isolate the variable or the term with the variable x. Yes, that's negative 3x and positive 3x. Okay, simplifying this equation will give us 6x plus 4 is equal to 10. That's 3x plus 3x is equal to 6x. Just bring down 4 and then simplify negative 3x plus 3x. That's simply 0. And put positive 10 alone. Don't you worry. Positive 10 will be inserted with negative 4 and on both sides of the equation. Therefore, by subtraction property of equality, we have the next step. 6x plus 4 minus 4 is equal to 10 minus 4. Let's simplify. Yes, 6x is equal to 6. Then, what is the number multiplied to 6 that will give us 6? Is it 0 or 1? To give you a clue, let's divide both sides of the equation by 6. Therefore, 6x divided by 6 is equal to x. And then 6 divided by 6 is? Correct. That's 1, not 0. Therefore, x is equal to 1. But we're not yet done because we want to find the value or the measure of each side. Solving corresponding parts of congruent triangles again. If x is equal to 1, then what are the measures of side AB and PQ? Here's the solution. Since side AB is equal to 3x plus 4, we may substitute x is equal to 1, and 3 times 1 is 3. Add 4 from the right expression. Therefore, we may get 7. And 7 is the measure of side AB. Following that is 7 units. How about the other side of the equation or the triangle, the yellow one, triangle PQR? Since side PQ is equal to negative 3x plus 10, we may now substitute the solved value of x is equal to 1. Negative 3 times 1 is equal to negative 3, and plus 10 will give us 7. Or 10 minus 3 is 7. Therefore, side PQ is equal to 7 units, which is, by truth, side AB, which is 7 units, is also equal to side PQ, which is also 7 units. Proved. There you go. That's how you prove corresponding parts of congruent triangles and solve for their corresponding parts. All right, now we learned how to prove and solve missing angles or sides of congruent triangles using CPCTC. Let's try if you can prove corresponding sides of congruent triangles. Feel free to answer each question. Please don't forget to indicate the number or numbers for each answer, as well as your full name and section, so that your respective math teacher will acknowledge your comment. For activity 1, given M is the midpoint of FG and OP. Forget, that point is the middle part that cuts that side or segment into 2 equal parts. Please prove that side FO is congruent to side GP. Okay? Again, please prove side FO is congruent to side GP with this given statement. You have 2 minutes. Good luck. Again, what is the first statement and what is the reason for that statement? Twenty seconds. Okay. 5, 4, 3, 2, and 1. Now, let's discuss. We have here Jezreen Angeles or Rian Jezreen L. Angeles from grade 8/1. For number 1, M is the midpoint of side FG and side OP. That is given. Also from Princess Althea Valdez from grade 8/1 also. M is the midpoint of side FG and side OP. Yes, that is given. From Jerome Nicodemus from grade 8/4, M is the midpoint of line FG and OP. Very good, that is also given. Renia Joy de la Cruz. Okay. Zeldrick Rodriguez. Tara Roque. Anika Beatriz Marasigan. Angel Nicole Carlos. Rain Panganiban. Denise Francesca. Jan Loren de Guzman. Micaela Calayag. Roy Carmela Cua. Carmela Talamayan. Okay. Let's see. Very good. M is the midpoint of FB and OP. That is also given. How about number 2? Yes, that is the midpoint definition. Okay, let's see who got the correct answer for number 2. Yes, that's Riley Villanueva. Okay, correct answer for number 2, definition of midpoint from grade 8 Kisumbing. We also have answers from Mark Jacob Ramos, Cassandra Peneno, Remy Zamora, Chris Wyatt Avila, Jovel Handonero, Maricel Bartolome, Laila Gianna Kaluwag, Erwin Fabian, Angel Joy Panganiban, thank you, Janelle Carpio, Jared Ignacio Centeno, Jeniel Maika Lopez, Janelle Cabrillos, Rian Martin. Okay, let's see for number 3. Okay. Have you seen those markings on our triangle? Yes. That's for statement 1 and 2. Okay. Angle OMF is congruent now to angle PMG because vertical angles are congruent. Let's see who got the correct answer for statement number 3. Okay. Next, for number 4, therefore, triangle OMF is congruent to triangle PMG. Have you seen those markings? Those markings will give us clue which triangle congruence postulate is used or shown on our given, supported by our statement and reason. Okay, number 3. Yes, that's correct from Janelle Maica Lopez and Luis Gabriel Dorado Cardozo. Riley Villanueva also got the correct answer for number 3. Okay, since we have 2 sides and 1 included angle, correct, that's side angle side congruence postulate. And therefore, number 5, side FO is now congruent to side VP by CPCTC. There you go. And for our second activity, given that triangle OMF is congruent to triangle PMG, let's find the measure of angle F and angle G with 8y minus 3 degrees for angle F and y plus 46 for angle G. Let's see. Let's solve for the value of y on the given activity. Again, feel free to answer each question. Please don't forget to indicate the number or numbers for each answer as well as your full name and section so that your respective math teacher will acknowledge your comment. You have 60 seconds. Good luck. Okay, there you go. 60 seconds have left. These are the steps on our solution, and you have to identify all of those uh, portions or parts that were covered. Okay, we have the solution that angle F is congruent to angle G by CPCTC, proven that triangle OMF is congruent to triangle PMG. Okay, so let's have our first statement or first step of solution. 8y minus 3 is equal to, correct, that's y plus 46 by definition of congruent angles. Okay, and angle F measures 8y minus 3 degrees, while angle G measures y plus 46 degrees. For the third step, we have 8y minus 8 minus y minus 3 is equal to y minus y plus 46 by what property of equality? Okay, let's see some examples or some answers from the comment box. Okay, so we have answers from Andre Alfaro Martel from grade 8-3. Renia Joy de la Cruz from grade 8-2. Jerome Nicodemus, Hannah Graciela Segura, Mark Jacob Ramos, Ayla Jana Di Caluag, J. Menjola, or Reynaldo M. Menjola III from grade 8-15. James Cruz, Heaven Agustin, Jezeri Angeles, Prince Gabriel Chico, Ralph Nathan Mansilungan, okay, Jessian Mizelaya de la Cruz, Carmela Talamayan, Maricel Bartolome, Dennis Francesca from grade 8 Alcala, Jonah Cruz, Anika Beatriz Marasigan, Dennis Salandanan, okay, correct. That is subtraction property of equality, since we already subtracted or we use negative y on each side of the equation. How about number 3? That is how we simplify 8y minus y. That is 7y. Correct. Number 4, on each side of the equation will give us positive 3 by addition property of equality, inserting positive 3 on each side of the equation, or plus 3. Okay, and then therefore, negative 3 plus 3 is 0, and 46 plus 3 is equal to 49. By simplification, we now have 7y is equal to 49. Okay, there you go. We have answers from Angel Joy Panganiban from grade 8-2, Adriana Chloe Demission from grade 8 Gomez. Okay. Rain Panganiban, your answers are correct. Yes, that's y is equal to 7 because 7y divided by 7 is y, and 49 divided by 7 is equal to 7. That's by definition of, or division property of equality. Yes. These are the correct answers. Great job. Almost all of you got the correct answers, huh? Very good. But we're not yet done. Yes, we should not miss the measures of each angle. Let's take 30 seconds to answer that. There you go. Here's the solution. Substituting y is equal to 7. Y times 7 is equal to 56. So minus 3 will give us 53. And y plus 46, or 7 plus 46, will also give us 53 on each angle F and angle G respectively. Okay. There you go. You are truly math wizards. Very good. Let's continue the discussion with the different properties of an isosceles triangle. What are the parts of an isosceles triangle? In an isosceles triangle, the congruent sides are called the legs. There you go. That's side PR and side PQ. Yes, we call it as leg. Okay. The angles that are opposite the legs, okay, are called base angles. Have you seen those blue ones? Yes, that's the base angle. Okay, and they are congruent. How about the side that they include? Yes, that is side RQ, which we call the base. How about the upper part or the upper angle of the triangle? Have you seen that? The angle opposite the base is what we call the vertex angle. Please don't forget, we have the legs, the base angles, the base, and the vertex angle. Then we can now have the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. If the hypothesis is having two sides of a triangle are congruent, then what would be the conclusion? Yes, having two sides of triangles are congruent will give us two angles are also congruent, which are opposite the leg. Each leg has an opposite base angle and they are also congruent. Let's see. Who can identify the correct statement? Is it the first one? All equilateral triangles are isosceles triangles, or isosceles triangles are equilateral triangles? 30 seconds. Let's see. Is it statement one or statement two? All equilateral triangles are isosceles triangles. Yes, that is the correct statement. All equilateral triangles are isosceles triangles. But not all isosceles triangles are equilateral triangles. When we say equilateral triangle, those angles having all equal sides, or we can say that all three equal sides are congruent. Okay, but it also possesses the property of an isosceles triangle having two sides of equal length. Okay, but this is an this is a special triangle. The equilateral triangle doesn't only have two equal sides, but all three sides are congruent. Therefore, all equilateral triangles are isosceles triangles. Now, what will happen to the angles of all equilateral triangles? Let's see as we go on with this discussion. The corollaries of the isosceles triangle theorem states that an equilateral triangle is also equiangular. And corollary number two, all equilateral triangle has 360-degree angles. Following the triangle angle sum theorem, which is equal to 180 degrees, no more, no less, that's exactly 180 degrees for the internal angles of a triangle. Then let's divide that angle into three equal angles. We may have 60 degrees on each angle. Okay. Again, corollary number one, all equilateral triangle is also equiangular. And corollary number two, an equilateral triangle has three 60-degree angles. Please take note, when we say equilateral triangle, we are focusing on the sides or the three equal sides of a triangle. Can be represented for equal, and lateral, maybe it means side. Equiangular is equal angle, okay, or equal angles. Let's continue. Corollary number three, the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Let's say we have triangle PQR, extending a line from point P and to the middle of RQ will give us point M. And yes, have you seen those markings? RM and MQ are now equal. As well, it also gives perpendicular angles shown on the square corner. During the presentation of the proof of isosceles triangle theorem by the early mathematicians, they discovered another set of statements that are apparently true. These are the corollaries as we have discussed. Again, please take note and please remember that corollaries are theorems connected by a short proof to an existing theorem. Then let's have the converse. If two angles of a triangle are congruent, those are the base angles, then the sides opposite those angles are congruent, as we have discussed earlier. Then, if the hypothesis is if the triangle has two congruent angles, then what would be the conclusion? Yes, having two equal or congruent sides. And please take note, all equiangular triangles are equilateral, having all equal sides and all equal angles. This lesson really takes too much activity for your brain cells, right? Well, better use it than just skip it, right? Now, I challenge you to take this last activity to test your math skills that we acquired during the discussion. Again, I will give you 2 minutes to answer. Good luck. Maybe you have some topics or points that aren't clear for you. Don't worry, the Teleradio team will upload this episode on Facebook and YouTube. So don't forget to follow, subscribe, click like, and share this video on our Facebook page. And of course, our YouTube channel. No available resources for our social media platforms. Your respective mathematics teachers got you. We have Ma'am Emma Garcia, Ma'am Pearl Laksa, Ma'am Charito Ferrer, Ma'am Chelsea De Luna, Sir Emer Narciso, Ma'am Lailani Rio Pirio, Sir Marlon Atienza, and of course yours truly, Sir Richard Cruz, to entertain your questions through Messenger or SMS. 45 seconds. 20 seconds. Yes, for activity 3, we were given that an isosceles right triangle MHP with angle bisector HS and MP is equal to 29.7 units. Let's find the unknown parts. You can take a screenshot of this activity and answer on your own. These are the correct answers. Did you get all of those answers correct? Great job. Now you are ready to answer the assessment part of your module. That's an episode full of learning. Now you're ready to answer the assessment part of your module. Do you have questions, ideas, suggestions, or clarifications in mind? Please do not hesitate to contact your mathematics aid teacher. I would like to take this opportunity to thank our very youthful Dr. Vivo, the principal of Marcelo H. Del Pilar National High School. Of course, the assistant principals, especially our department head who never get tired, Sir Marco, hello po, magandang umaga, as well as Ma'am Madonna Estacio. Also to my colleagues from the Junior High School Mathematics Department who are now watching with us, thank you po. And of course, this Teleradyo episode will never be possible without the hardworking technical group with Ma'am Hilda, Ma'am Bernadette, Ma'am Isabel, Sir Paulo, maraming salamat po, and Sir Frederick. Mabuhay po kayo. I am Sir Richard, your Mathematics 8 teacher for this week na nagpapaalala mula sa Love Radio. Una, magdasal ka para mabuhay ka. Pangalawa, mag-face mask ka para mabuhay naman ang iba. Yon. Again, this is Sir Richard now signing off. Salamat po.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.